So in the last class, we are discussing about the pH scale, remember?
Yes.
Okay, so today we'll discuss about this universal indicator paper. What is universal indicator paper? So we can find the pH of any solution by using universal indicator. Okay, so universal indicator, it is a mixture of dyes. Like litmus, it can be used as a solution. Like litmus can be used as a solution, litmus can be used as a paper strip. Similarly, this universal indicator, it can be used as a solution also and as a paper strip also. So what's the significance of this universal indicator paper? That its color changes with pH. For example, if pH is 1, then the color is dark red. If pH is approximately 3 to 4, then the pH color is your orange in the universal indicator paper. If the pH is 5 to 6, it is yellowish green. And pH 7, it is green in color. So pH 7 is our neutral, right? So at the neutral one, it is green in color. Then we move to the alkaline part. Here we have 8 to 9, it is greenish, and then 10 to 11, it is blue. And in the highly alkaline solution, that is 13 pH, it is violet in color. Okay, so at the high pH, very high pH, its color is violet. At very low pH, its color is red, and at neutral pH, its color is green. Okay, so we can find the pH of any solution by using this universal indicator. Okay, here, write it down. Once you are done, please let.
Done.
So let's see acids. Let's read about acids more. Acids produce hydrogen ions. Okay. So for example, see hydrogen chloride. It is a gas which is made up of molecules. Okay. When you dissolve it in water, it makes up an aqueous solution. Okay. So it is known as now hydrochloric acid. Okay. This is not molecular. Why it is not molecular? Because in water, if you dissociate in water, the molecules will break up or they dissociate into ions, into H plus ions and Cl minus ions. So it is producing H plus ions. So HCl is a acid. So acids are those substances which releases hydrogen ions in the aqueous solution. Okay, write it down.
Done.
So now let us see the difference between strong and weak acids. What's the difference between strong acids and weak acids? So let us see in the solution of hydrochloric acid HCl, all the molecules of hydrogen chloride they have become ions. That means it is 100% dissociated into ions into H plus and Cl minus ions. So we can say that it is a strong acid. Hydrochloric acid is a strong acid. But in weak acids, only some of the molecules become ions. For example, let us see ethanoic acid, or it is also known as acetic acid. So here, much less than 100% are breaking into ions, okay, into H plus ions and the CH3PO minus ion. So what you have to remember, the difference between strong and weak acids is that in solutions of the strong acids, all the molecules become ions, okay. But in solutions of weak acids, only some do, because the dissociation is much less than 100%. Okay. So strong acids conduct better. Now, if I ask you that which conducts better electricity, strong acids or weak acids, the answer should be strong acids, because in the strong acids there are more ions which are present. Okay, so which conduct electricity far better than the weak acids. If we talk about pH, then they have a lower pH. Why? Because you know that pH is inversely proportional to the hydrogen ion concentration. pH is inversely proportional to hydrogen ion concentration. Now in strong acids, hydrogen ion concentration is larger, so pH is lower. So higher the concentration of hydrogen ions, the lower the pH. So it's a very important point. Okay, so write it down.
Done.
So next we'll talk about alkalis. Alkalis produce hydroxide ions. As we discussed that acids produce H plus ions, but alkalis produce hydroxide ions. Hydroxide means OH negative ion. Okay, so the best example is sodium hydroxide. It is an ionic solid. When it dissolves in water, it dissociates into Na plus and OH minus ion. So this is also 100% dissociation because it is a strong base. So sodium hydroxide, it contains hydroxide ion, OH minus ion. So similar is true for all alkaline solutions. Solutions of acids contain hydrogen ions, but solution of alkalis contains hydroxide ions. Solution means when you dissolve it in water, then you have OH minus ions which are present, which are released. Okay. Write it down.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Done writing.
Yes.
Okay, now let us see the table which shows us the conductivity value. So we have three alkalis we have taken: sodium hydroxide, that is NaOH, potassium hydroxide, KOH, and the ammonia solution, that is NH3. So you know that these two are strong bases, and this last, that is your ammonia, it is a weak base. So let us see the table for a 0.1 molar solution. This is the concentration which is given of the solution. So conductivity is measured. It is measured in the unit microsiemens per centimeter. So it is 20 for sodium hydroxide. For potassium hydroxide, it is 50. And for ammonia solution, it is 0.5. Okay. So here we know that as for weak acids, the conductivity is very low. For weak base, the conductivity is very low. The first two alkalis, that is your sodium hydroxide and potassium hydroxide, they have high conductivity and they have high pH. Because they are strong bases, they release OH minus ions in a larger amount. Okay, that's why its pH is about 30. But the ammonia solution, it shows very less conductivity, only 0.5. Okay, and a low pH 11.1. That means it is basic, but not that basic as sodium hydroxide and potassium hydroxide. So it is a weak alkali. So for the strong alkalis, they have high conductivity and high pH, and for weak alkalis, they have lower conductivity and lower pH. This you have to remember. Write it down.
I'm done.
So now why ammonia solution is behaving different from sodium hydroxide and potassium hydroxide, let us see. So in sodium hydroxide solution, all the sodium hydroxide exists as ion. It completely dissociates 100% because it is a strong base to give you Na plus ions and OH minus ions. Similarly, potassium hydroxide also, it is also a strong base. It will dissociate in water to give you K plus ion, potassium ion, and OH minus ion. But ammonia gas is molecular. It is molecular. When it dissolves in water, what happens is that it takes the proton from water and it becomes NH4 plus. Okay, and water becomes OH minus. So this dissociation is much less than 100%. So here only some of the ammonia molecules, they form ions. So there are fewer hydroxide ions. These hydroxide ions are in the less quantity as compared to that which are present in the sodium hydroxide solution, if we take the concentration to be same. So which is better conductor? So as already stated, that sodium hydroxide solution is a better conductor than the ammonia solution because it contains more ions. and it has a higher pH because it contains more hydroxide ions. Okay, so the higher the concentration of hydroxide ions, the higher the pH. So it is just opposite of that. That higher the concentration of hydrogen ions, lower the pH, and higher the concentration of hydroxide ions, higher the pH. So that's why your ammonia is not a good conductor as compared to your sodium hydroxide and potassium hydroxide. Okay, because the OH minus concentration of OH minus ion in ammonia is lesser as compared to NaOH. Clear? Write it down. Okay. So this is your homework question. What do all alkaline solutions have in common? Write an equation to show what happens when ammonia gas dissolves in water. So we all have studied these. You have to write it down in your homework. Let us study some reactions of acids. That with acids react with metal to form salt and hydrogen. For example, let us take sulfuric acid, which is H2SO4. It reacts with metal such as magnesium to form a salt, that is your magnesium sulfate, okay, and hydrogen gases evolve. What happens? Metal drives the hydrogen out of the acid and takes its place. So it displaces the hydrogen because metals are more electropositive than hydrogen, so it displaces the hydrogen from its position. A solution of the salt magnesium sulfate is formed. So this reaction is important, that what happens when acid reacts with metal. Acid reacts with metal to form salt and hydrogen gas.
Done.
Okay, now let us see the reaction for bases also. That same reaction happens. That acid, it reacts with base to form salt and water. So this reaction is also known as your neutralization reaction. So what are bases? Bases are compounds which react with the acid to give only a salt and water. Now metal oxide and hydroxides are bases and alkalis are soluble bases. For example of reaction C, hydrochloric acid reacts with base sodium hydroxide to form a salt, that is NaCl plus water. Okay, so let us see this acid, sulfuric acid, it reacts with a base. This is metallic oxide. Copper is metal and its oxide is metallic. Okay, so it is basic oxide. So acid reacts with base to form again salt and water. So these reactions are very important. Write it down.